Welcome back. This is Mr. Hassan's Maths channel. I'm now answering a question from an old paper from May-June 2012 from the 0580 IGCSE Cambridge. It's paper 4, variant 1. And this question actually comprises quite a few different topics mixed up in the same question as you normally find in paper 4. And the first part of this question here is about this circle. And in this circle, they've told us a few bits of information that A, B, C, and D are all points that lie on a circle. That means on the circumference of the circle, which has a center of O. AB is equal to 7 centimeters, BC is equal to 10 centimeters, and the angle AB equals 77 degrees. All of those things are already marked on the diagram. It says AOC is the diameter of the circle. So we've got to find the angle ABC, which is the angle over here. So we've got to find this angle over here, ABC. Now this angle here, okay, is, if we think about our topic of angles in circles, right? It's got something to do with angles in circles, of course. So now, if we think about this, one of the first things you should do when you want to try to find the size of an angle is you should try to trace back where the angle actually originates from. Now, what do I mean by this? Angle ABC. So the angle's at B. Let's trace the arms of this angle back. Where do they come from? So this angle comes from this arm of the angle comes from C, and the other arm of the angle comes all the way from A. So you can see that this is basically standing on this line AC, or this. In fact, it's standing on the diameter. AOC is the diameter. So we should know one of the rules of in angles in circles is any angle which is standing on the diameter is going to be 90 degrees. Okay, so this is definitely 90 degrees. So that's part A. Angle ABC is 90 degrees. They didn't tell us to give a reason, but if you want to give reasons, you can say angles in a semicircle. That's enough for the examiner to understand. In this case, you don't have to write this, but just in case you do, that's how you would describe the reason for this answer. This angle standing on the diameter, you can say angles in a semicircle. That gives them the understanding. All right, so that's part A, angles in circles. Then it says part B, calculate angle ACB, showing that it rounds to 35 degrees, correct to the nearest degree. So the angle ACB, this is the angle they want us to find. Okay, let me call it angle X. We want to find angle X. Now we already determined that here we have a right angle. So this is a right angle. So basically we have a right angle triangle here. This is a right angle triangle. If I again just highlight that to make it clear. All right, this is a right angle triangle. This angle ACB is part of this right angle triangle. Okay. The fact that it says show that it rounds to 35 degrees correct to the nearest degree gives me an idea. I'm not going to be using like angles in circles here. I'm going to have to use some sort of other method like trigonometry, which will give me something which I have to round to in general. So that's why we can be clear that we're not looking at other angles and stuff here. We're trying to look at something like trigonometry. And we can see that we have a right angle triangle. In this right angle triangle, we know the side which is opposite the angle we're trying to find. We know the side which is adjacent to the angle we're trying to find. So we've got a right angle triangle, so we can think about SOHCAHTOA, the trigonometry of right angle triangles, and we have opposite and TOA, sorry, SOHCAHTOA, what am I doing? Okay. So we can see we got the opposite and we know the adjacent. So in relation to the angle that we're trying to find, we know what's opposite it and what's adjacent to it. This is the hypotenuse. We don't know the hypotenuse. So we're going to be dealing with the opposite and adjacent, which, as you can see, we have to deal with tangent, the tangent ratio. Opposite and adjacent is a tangent. So we're going to say that the tangent of the angle that we need, which we've called X, is equal to the opposite side, which is 7, over the adjacent side, which is 10. So that means the angle we need is the inverse tan of 7 over 10. Okay. So we take the calculator, make sure that we are in degree mode, which we are. Shift tan and 7 over 10. And that gives us the angle, which is 34.992. X equals 34.992. Let's make sure of that. Yep. Now the question says, show that it rounds to 35 degrees, correct to the nearest degree. So we should always do that. We should always show, okay, what it was before it's rounded. If they say show that it rounds to, always show what it was before it's rounded. So write this to more degree of accuracy than you need, and then show that, of course, if you round this to the nearest degree, this is going to become 35 degrees. Okay, now another point is, generally, if they didn't mention this, if they didn't mention show that it rounds to, we would give our answer as 35.0, because you'd round it to one decimal place for degrees, one decimal place, which will cause this to become a 10, which will cause this to become a 5, so you have 35.0. But because it says to the nearest degree, we'll give our final answer to the nearest degree. And we've shown what it was before it was rounded to, follow these instructions. So always when it says show that it rounds to, always write it write it to what it was before it was rounded, at least to a couple of more decimal places, and then show that how it rounds to what they want us to round it to. So there's the answer for part B. Okay, so what I'm going to do here, in case I need to use this answer further on, I'm going to store this answer as A. So this is now A in my calculator. So I'm going to put here a little thing just for myself to remember. That's the answer A in my calculator. Now, the next part of the question says, explain why angle ADB is equal to ACB. ADB, which is this angle over here, is equal to angle ACB. ACB, which is the angle we just found. Okay, why are they equal to each other? All right, for a very similar reason as we talked about earlier. If I just get rid of some of this stuff here, I'll just get rid of some of this stuff to make it clearer. So we're showing why this angle is the same as this angle. Okay, and again, if you want to do that, you should try to follow the angles back. So the angle ADB is at D. That's where the angle is. If you follow where it comes from, it originates all the way back from here, A. And the other arm of it originates all the way back to B. And the angle ACB also, it originates all the way back to A. And this one originates all the way back to B. Both of those two angles are subtended by the same arc, AB, and they're both on the circumference of the circle in the same segment. Okay, so you can say that they are subtended by the arc, so both subtended by the arc AB, and they are in the same segment. Okay, so if you just write same segment, that's enough. Even if you just write same segment, they will understand exactly what you mean. Okay, this is a bit more than what you need to write, but just for your understanding that they're subtended by the same arc and they're on the circumference in the same segment. I mean, the full explanation would be they're both subtended by the same arc, they're both standing on the same arc, and they're both on the circumference, they're both formed on the circumference, and both in the same segment. This is the minor segment, this is the AB is like the chord, all right? This arc AB forms this chord as well. So on this side is the minor segment, on that side is the major segment. They're both in the same segment, same major segment, according in relation to AB, and both of them, they are on the circumference, standing on that chord AB. So that's the reason why these two angles are the same. Okay, so that's part C, and now we're going to go on to part D. Now part D says calculate the length of AD. The length of AD, let me call this length Y. Now we already determined what this angle is, okay, and we already determined that this angle is the same as that angle, okay. So we know that this angle is the same as that angle, and the angle was 35, but before we rounded it, it's always best to use it in a more accurate form. Before we rounded it, it was 34.992. 34.992. So this angle here was 34.992. Therefore, this angle is also 34.992, which I saved as A in my calculator. So now I have this triangle here, and I can see that I can use another type of trigonometry. We don't have a right angle triangle anymore, but we have something that will help us. So if I look at the triangle AED, it's a bit thick there, it doesn't matter. This triangle here. In this triangle here, I have this angle, okay, which is over here. No, sorry, not that triangle there. The other triangle. Let me just make that a bit. Sorry. I'm talking about a different triangle. I'm talking about this triangle here. ABD. This triangle, sorry. This triangle here, ABD. Now in this triangle, what do I have? I have one of the angles and another angle. I have these two angles. I have this side and I want to find that side. So I can use the sine rule here because it's not a right angle triangle, so I can't use anything to do with the right angle triangle trigonometry. However, I have a pair of opposites. I have y and 77. One of them I have to find, the other one I know. And I have the angle 34.992 and I have the side 7. These are a pair of opposites. I know both of them. Here's a pair of opposites. I need to know one of them. I know the other, so I can use the sine rule. Okay, so here I can use the sine rule. And as I'm trying to find a length, I'll use it in this form. Now, the sine rule basically states that a over sine A equals b over sine b, something like that, where a and b are opposite. So any length in any triangle, whether it's right angle or not, any length divided by the sine of the angle opposite that length will give you the same ratio as another length in the same triangle divided by the sine of the angle opposite that length. So I know that y divided by sine 77 will give me the same answer as 7 divided by sine 34.992. Okay, that's the sine rule. So I can say that y divided by the sine of 77 degrees is the same answer as 7 over the sine of 34.992. Now, a lot of people forget to write sine. They just write the length over the angle. No, so the length over the sine of the angle. That's very important. Don't forget that. Otherwise, your answer will be completely wrong. So 7, if I cross multiply 7 times sine 77 over the sine of 34.992, and that will give you my answer, which in the end I'll round to 3SF. So let's take the calculator again. Okay, so I have 7 times the sine of 77 divided by, and I'm going to have the sine of, now I already stored my answer as A, so I'm going to press alpha A, and it will give me the answer A. Okay, so sine A was my answer for this angle which we found earlier. So that will give me my answer, which is 11.8937. So 11.8937. So to 3SF, that's going to be 11.9 centimeters, because it didn't say how to round it. So we round to 3 significant figures. So there is the answer to part D, part 1. So what I'm going to do also now is I'm going to add this answer, and I'll store it as B in my calculator. So I've got the exact answer for that. I always like to use exact values for subsequent parts of the question. All right, so now part 2. So that's D part 1. Now D part 2, it says calculate the area of triangle ABD. So I want to find the area of this triangle ABD. Okay, so it's this triangle over here, ABD. We need to find its area. Now, so far now, we've got some information from this previous part of the question. We know that this length is now 11.8937, which is B in my calculator. We also know that this angle here is the same as the angle here, as we determined already, which is 34.992. That's angle A. That's A in my calculator. That's B in my calculator. All right. Now, with that information, I need to find the area of this triangle. Now, we have a formula that the area of a triangle, when we don't have its vertical height, is a half times AB times sine C. Now, we can't just randomly use any lengths and any angle. It has to be two sides and the angle between them. Now, in this triangle, I have these two sides. I don't have this third side. So I need to use this angle to find the area of the triangle using this formula. So I need to know what this angle here is. I need to know what this angle here is. Let me call this angle Z. So I can say the angle Z here, or let me just call it by its actual name, which is angle, this is angle DAB or BAD. So angle DAB is going to be 180 minus, it's basically the third angle, we know the other two angles, minus 77 plus 34.992. So this will be angle DAB. So what I'll do is I'll take my calculator and I'll do 180 minus, and I've got 77 plus, and then I'm going to use the angle which I saved as part A in my memory there. So that's going to give me the angle that I need, 68.0079. 68.0079. So this is the angle here, 68.0079. And I'll also save this in case I need it as C. So I'll store this as C. Okay, so that's now C in my calculator. I'll just put a little mark there so I know. So now the area I'm looking for is going to be equal to 1/2 times A, which is 7, times B, which is 11.8937, times the sine of the angle between them, which is 68.070079. Okay, so that will give you my answer. So I can just take my calculator here, and this is now C in my calculator, which I've already marked there, so no problem. So I'll have 1/2 times A, which is 7, times B, which is actually our B in the calculator as well. So I'll put alpha B, that's 11.8937, times the sine of the angle between them, which is our C. Okay, alpha C, that's going to give me the proper answer, which is 38.5989. So 38.5989. So this doesn't tell us how to round it. So 3SF, that's 38.6 square centimeters. There's part 2 of question D. And now for part E, which is the final part of the question, which is here, it looks like it's to do with similarity, as it says similar triangles. So it says the area of triangle AED is 12.3 centimeters squared, correct to 3 significant figures. Okay, so we have here this triangle over here, AED, which is this one here. This triangle here has an area of 12.3 square centimeters. So that's 12.3 centimeters squared. Use similar triangles to calculate the area of triangle BEC. BEC. Okay, so we got to use similar triangles to calculate the area of BEC. Now, the reason why they're telling us to use similar triangles, because I'm sure there could be other ways of finding that area, okay, using trigonometry maybe, but they want us to use similar triangles. So what we can see here is that these two triangles are similar. And how do we know they're similar? Well, we already established that the angle ADB is the same as the angle ACB. We already established that. They are, the reason for that is that they are in the same segment, angles in the same segment on the same arc on the circumference. Okay, and so these two angles, we know that they're the same. We can also say that this angle and this angle are the same because they are vertically opposite. So I can say that the angle AED is the same as angle BEC. Okay, that's because they are vertically opposite angles. So therefore we can say that triangle AED is similar, which can be also used, you can use that symbol there, that means similar to triangle, and we have BEC. They're similar triangles. And as they're similar triangles, we can find the length. I know that this length is 11.8937, this exact form, which, as again, I stored it as, I think, B in my calculator. That's B in my calculator. Right, so I know that length, I know this length, I know the area of this, I can find the area of this triangle here. So the area that we're looking for is equal to, we can say the area that we know, which is 12.3, times, now the ratio of the areas, well, we got, this is, A is a smaller triangle, so I'm going to use, so I know that the area of this is going to be smaller, so I'm going to use the smaller length over the bigger length. However, this is the ratio of the lengths. I'm finding an area. This is an area. I need to square this ratio to give me the ratio of the areas. Another way of doing it is saying the area that you need over the area that we have is, well, we can't say it's equal to yet. That's the ratio of the areas of these two triangles. And we know that 10 over 11.8937, the length on the one that we're trying to find, which is same as A, over the length on the one that we know. Okay, that's the ratio of the lengths, that's the ratio of the areas. If I square the ratio of the lengths, it will give me the same thing as the ratio of the areas. That's another way of setting out your work. So therefore, in either case, you'll end up with this area is equal to 12.3 times that. So the area is going to be, if we work that out, we say 12.3 times, I'm going to put bracket, fraction bar, 10 over, that's B in my calculator. Yep, that length is B in my calculator, so I'm going to put alpha B, and then I'm going to square that. That's the ratio of the lengths. Okay, squared gives you ratio of the area, so that should give you my answer. The answer should be less than 12.3. Let's see what it comes out as. 8.695. 8.695. So you can say 8.70 centimeters to 3 SF. Okay, and there's the answer to this question. And that completes this question. I think that's it for this question. Yes, that's up to number 4. So that completes this question number 4 from the May-June 2012 paper 4 variant 1 Cambridge 0580. Other questions from this particular paper you will find in the playlist that will be appearing over here at the end of the video. The link will be over there, you can click it. Other questions dealing with angles in circles from IGCSE, you can find it in the playlist that will appear in this region over here. Other questions from trigonometry from IGCSE, you'll find in the playlist that will appear over here. And other questions involving similarity, you can find in the playlist that will appear over here. So I'll put this question in all of those different playlists. So, you know, it's dealing with all of those different topics. And at the top here, you'll find a link during the video as it's playing to a video which tells you how to use my channel to find the things that you might be interested in. Thank you for watching and see you soon.